Don't blame me.
An automotive battery converts stored chemical energy into electrical energy to power the car's accessories. But unless the materials inside the battery are chemically balanced, the reactions that produce electricity will no longer occur. The battery uses electrical energy to maintain the appropriate chemical balance. Electricity directed into the battery reverses the chemical reaction that occurs when current is produced. But a battery can't provide the electrical energy needed to charge itself. How does the car's electrical system recharge the battery? The automotive charging system uses energy from the internal combustion engine to generate the current that charges the battery. Let's look at how this is done. You've seen how the close relationship between electricity and magnetism is used in the starter motor. Well, the charging system uses that relationship in similar ways. An electric current creates a magnetic field around a conductor, but a magnet can also generate an electrical current. The process of generating electric current through magnetism is known as induction. Induction occurs when a wire is moved through a magnetic field. The magnetic field acts on electrons in the wire to create an electrical pressure or voltage in the wire. Induced voltage causes current to flow in a wire when the wire is part of a circuit.
A wire and a magnet are required for induction to occur. However, there is also one more critical requirement to produce electric current through induction. What do you think is the third requirement? Is it a heavy enough magnet, high-density shielded wire, movement of the wire or magnetic field, or is it a battery housing?
The movement.
Use your mouse to select your
How
answer.
fast the movement?
Right, there is some gentlemen requested to watch this movie, and we have way too much talking going on.
See, yeah, all right, let's go keep it going. Okay, let's keep it going.
No, I need to calm your tits.
Current
Hey, Harry.
What? Huh?
Either way, a voltage is induced in the wire. Without movement in either the field or the wire, there will be no induction and no voltage. This same principle is used in the design of the alternating current, or AC, generator.
How do you make a magnet?
First, you need some iron. You need magnetism.
The AC generator is also commonly called an alternator. The generator is the link between the rotational force of the engine and the electrical energy necessary to power the vehicle's electrical system. The AC generator evolved from earlier systems that used a direct current or DC generator. The DC generator and the AC generator both use the revolution of the engine to drive a belt that powers the generator's pulleys. This allows the mechanical energy of the rotating engine to be converted into electrical energy. The most significant difference between the two is where the electrical energy is generated. In the DC generator, the armature rotates inside a fixed magnetic field. This produces a current in the armature. In an AC generator, the reverse is true. The magnetic field rotates inside the conductor, and current is produced in the stationary part. For this reason, the conductor is known as a stator. In the AC generator, the stator coils are permanently mounted around the inner circumference of the housing. The field coils and their pole pieces are mounted on a shaft and rotate within the stationary stator. With a stationary stator, the AC generator output can be directly connected to an external circuit without the need for brushes. The voltages and current in the field windings are low compared to those of the stator. Since the field winding or rotor turns, slip rings must be used to connect the winding to its external DC exciting source. AC generators are more efficient because with a DC generator, high current output must travel through a set of brushes. This high current causes rapid wear and limits the amount of current that the unit can deliver. Another major drawback of the DC generator is its relatively low current output at low engine speeds. AC generators are much smaller and lighter than DC generators for the same current output. They have rapid charge capabilities, allowing the use of smaller batteries. They're also easier to diagnose and repair. The alternating current produced by an AC generator must be changed to direct current before it can be used by the vehicle's electrical system. Let's look at the problems presented by alternating current. Alternating current flows first in one direction and then in the other. AC is the type of current that is available in the electrical systems of our homes. It is electricity that is produced by electromagnetic induction. Let's look at a sine wave representation of what happens in an alternating current. The sine wave begins at 0 volts, climbs to a positive peak voltage, returns to 0, drops further to a negative peak voltage, and then returns to 0. The sine wave represents one cycle of alternating current. A complete cycle of alternating current is produced every time a magnet is rotated 360 degrees inside a coil of wire. In the windings of the stator, when one pair of magnetic poles from the rotor passes alongside one of the loops of wire that form the stator, a cycle of alternating current is produced. Rotating a magnet one complete revolution inside a coil of wire will produce one cycle of AC. This recurring cycle has one set of negative and positive values and is called single-phase alternating current. The amount of voltage induced in the stator is proportional to the number of lines of force which cut across the conductor in a given length of time. If the number of lines of force is doubled, the induced voltage will also be doubled. If the magnet is rotated faster, the voltage will also increase because the lines of magnetic force cut across the wire in a shorter period of time.
Which of the following actions will result in an increase in voltage? A. Increasing the magnetic field's rotational speed. B. Increasing the number of lines cutting across the conductor. Or C. Both A and B are required.
We agree it's C, right?
Good. You're right.
Technicians should keep in mind that either increasing the speed of rotation of the magnetic field or increasing the number of lines of force cutting across the conductor will result in increasing the voltage. Decreasing the speed of rotation or decreasing the number of lines of force will cause the voltage to decrease. Alternating current is useful in the home, but it cannot be easily used in the automobile. First, it can't be created chemically or stored. Second, its voltage changes as the magnetic field that creates it changes speeds. This means AC is not stable unless the speed of the magnetic interaction is controlled precisely. Finally, because current flow reverses direction in each cycle, it cannot be used to charge a battery, which depends on the steady flow of electrons for charging. The output of an AC generator must be converted to direct current before it can be used in an automobile. The AC generator is composed of a stator, rotor, diode assemblies, and the housings. A voltage regulator is also often found inside an AC generator. Outside the AC generator is a pulley. The pulley links the AC generator to the source of mechanical energy. This belt may also drive other engine accessories, such as the water pump and fan. The pulley turns a fan, which pulls cooling air through the AC generator. For the charging system to operate efficiently, AC generator output must be controlled. If the output is too low, for example, the battery could be quickly discharged. If the output is too high, the battery or accessories could be damaged. The voltage regulator is designed to limit current flow to the rotor when sufficient stator output has
Don't
been
take much
reached.
behind.
The primary function of the regulator is to prevent high voltage by limiting the generator voltage to a safe preset value. Let's look at how it works. The voltage regulator senses voltage at the battery. If this voltage is lower than the voltage regulator's set point, the voltage regulator turns on power to the AC generator's field coil. As the regulator measures a rise in voltage above its set point, it turns off the field current. A voltage regulator can be described as a voltage-sensitive switch. When the battery is low, the switch is closed, and maximum current is allowed to flow in the AC generator's field. When high voltage is sensed at the battery, the regulator opens its switch and turns off the field current. This on and off process occurs many times per second, thereby maintaining an overall output voltage level of approximately 14 volts. Voltage regulators are divided into two types. If the regulator completes the circuit between the battery connection and the field coil, it is called a B-type regulator. If the regulator is wired so that it completes the connection between the field coil and ground, it is called an A-type voltage regulator. If the voltage regulator isn't working properly, the driver may notice fluctuations in the performance of accessories. For example, the headlamps may brighten and dim as the voltage fluctuates. The modern voltage regulator uses an integrated circuit for electronic voltage regulation. The integrated circuit regulator is serviced by replacement only. Many vehicles use a concept called pulse width modulation to regulate rotor current. Let's take a look at how this works. A current sensing circuit determines the charging system load. Like other regulators, AC generator output is regulated by controlling rotor current. But this regulator switches the rotor off and on at a fixed rate of 400 cycles per second. This 400 cycle frequency remains the same regardless of the operating conditions, rotational speed of the AC generator, or electrical load. What changes is the amount of time the rotor is energized within each 1/400th of a second. The voltage regulator senses the electrical load and increases or decreases the on time of the pulses. By varying the on-off time, the proper AC generator output can be obtained. At high speeds with a low electrical load, for example, the on time of each pulse may be only 10%, while the off time is 90%. At lower engine speeds with high electrical loads, the on time may be 90%, while the off time is only 10%. The on time, off time is called the duty cycle of the regulator. Most voltage regulators control the warning lamp circuit. These lamps may indicate possible malfunctions in the circuit. There are two types of warning lamp circuits in general use. Most common is the system in which the warning lamp is connected between the car's battery and AC generator. When the AC generator is not charging, it serves as a ground for the lamp, turning it on. As the AC generator begins to charge, its output rises. When it becomes high enough to eliminate the difference in electrical potential across the bulb goes out. This principle, called equal and opposing voltages, is used to control the charge indicator. In the next video, we'll look more closely at the components inside the AC generator. Now, let's review the key segments of the program. 1. The automotive charging system uses energy from the internal combustion engine to generate the current that charges the battery. 2. The alternating current produced by an AC generator must be changed to direct current before it can be used by the vehicle's electrical system. 3. The amount of voltage induced in the stator is proportional to the number of lines of force which cut across the conductor in a given length of time. 4. The voltage regulator is designed to limit current flow to the rotor when sufficient stator output has been reached.
Let's check your understanding.
Is it in Chinese? Look what was coming next.
The voltage induced in the stator will decrease if there are more magnetic flux lines, will increase if there are fewer magnetic flux lines, will increase as the rotor turns faster, will increase as the rotor turns more slowly.
See.
See.
Skip it.
Escape. Escape. Escape.
The old CD. Scratched up. School didn't exist in stuff.
Let's watch this next one.
After viewing this presentation, you should be able to explain how the output of the AC generator is
Time was
rated.
going by so slow.
Describe the components used in the AC generator. Explain the differences between delta and Y stators. Describe the function of the diodes used in the rectifier bridge. Explain the process of rectification.
Rectifier. I'm a robot and listen to me talk.
So Zach.
Batteries starting and charging systems. Part 10, charging system components. The AC generator is a highly reliable and rugged unit, designed to provide sufficient current to recharge the battery and operate the vehicle's electrical components.
Yeah, we should watch this.
In this program, you'll look at the parts that make up the AC generator, and you'll examine the flow of current through some charging system components.
Intro.
Before we begin, let's take a moment to review how to work safely with batteries starting and charging systems. Always wear safety glasses in the automotive shop. Be sure to remove all jewelry before beginning work. Avoid wearing loose clothing. Tie back long hair and stay clear of moving parts such as belts or pulleys. Handle heavy electrical components such as batteries